The giant planets, Jupiter, Saturn, Uranus, and Neptune, are some of the most awe-inspiring in our solar system and have great importance for space research and our comprehension of the greater universe. Yet, they remain the least explored, especially the ice giants Uranus and Neptune, due to their distance from Earth and the extreme conditions spacecraft must survive to enter their atmospheres. As such, they're also the least understood planets in the solar system. Chris James and his colleague Yu Liu, the authors of this story, are researching how to overcome the harsh entry conditions experienced during giant planet missions. As they look forward to potential future missions, here's what they might expect. Unlike rocky planets, giant planets don't have a surface to land on. Even in their lower atmospheres, they remain gaseous, reaching extremely high pressures that would crush any spacecraft well before it could land on anything solid. There are two types of giant planets, gas giants and ice giants. The larger Jupiter and Saturn are gas giants. These are mainly made of hydrogen and helium, with an outer gaseous layer and a partially liquid metallic layer below that. They're also believed to have a small rocky core. Uranus and Neptune have similar outer atmospheres and rocky cores, but their inner layer is made up of about 65% water and other so-called ices, although these technically remain liquid, such as methane and ammonia. Any giant planet mission is extremely difficult. Still, there have been some past missions sent to the gas giants. NASA's 1989 Galileo mission had to slingshot around Venus and Earth to give it enough momentum to get to Jupiter, which it orbited for 8 years. The 2011 Juno mission spent 5 years in transit, using a flyby around Earth to reach Jupiter, which it still orbits. Similarly, the Cassini-Huygens mission run by NASA and the European Space Agency took 7 years to reach Saturn. The spacecraft spent 13 years exploring the planet and its surroundings and launched a probe to explore Saturn's moon, Titan. Flight times get even longer for the two ice giants, which are much further from the Sun. Neither has had a dedicated mission so far. The last and only spacecraft to visit the ice giants was Voyager 2, which flew by Uranus in 1986 and Neptune in 1989. While momentum is building for a return, it won't be simple. If we launch during the next convenient launch windows of 2030 to 34 for Uranus and 2029 to 30 for Neptune, flight times would vary from 11 to 15 years. A major issue is power. The Juno spacecraft is the most distant object from the Sun to have used solar panels. It orbits Jupiter, which is 5 times further away from the Sun than Earth is. Yet, where Juno's solar cells would generate 14 kilowatts of continuous power on Earth, they only generate 0.5 kilowatts at Jupiter. Meanwhile, Uranus and Neptune are 20 and 30 times farther away, respectively, from the Sun than Earth is. Power for these missions would have to be generated from the radioactive decay of plutonium, the power source for both the Galileo and Cassini missions. This radioactive decay can damage and interfere with instruments. It is therefore reserved for spacecraft which really need it, such as missions operating far away from the Sun. The massive scale of giant planets means orbit speeds for incoming spacecraft are incredibly fast, and these speeds greatly heat up the spacecraft. The Galileo probe entered Jupiter's atmosphere at 47.5 kilometers per second, surviving the harshest entry conditions ever experienced by an entry probe. The shock layer, which formed at the front of the spacecraft during entry, reached a temperature of 16,000 degrees Celsius, around 3 times the temperature of the Sun's surface. Even so, the distribution of the heat shield's mass was found to be inefficient, showing we still have a lot to learn about entering giant planets. Proposed future probe missions to Uranus and Neptune would occur at slower entry speeds of 22 kilometers per second and 26 kilometers per second, respectively. For this, NASA have developed a tough but relatively lightweight material woven from carbon fiber called HEEET, heat shield for extreme entry environment technology, designed specifically for surviving giant planets and Venusian entry. While the material has been tested with a full-scale prototype, it has yet to fly on a mission. In 2024, NASA's Europa Clipper mission will launch to investigate Jupiter's moon Europa, which is believed to house an ocean of liquid water below its icy surface, where signs of life may be found. The Dragonfly mission, planned to launch in 2026, will similarly aim to search for signs of life on Saturn's moon, Titan. There are plans for a joint NASA-ESA mission to visit one of the ice giants within the upcoming launch window. But while there has been extensive preparation, it's undecided which ice giant will be visited. A single mission to both planets is being considered. An entry probe is planned too, but if the mission visits both planets, it's undecided which planet's atmosphere the probe would explore. If we want to meet the upcoming launch window, its expected mission concepts will need to be finalized by 2025 at the latest. In other words, crunch time is coming. Should a mission go forward, the two most important goals for NASA's scientists will be to determine the interior makeup of ice giants, exactly what they are made of, and their composition, how they are formed. Other objectives will include studying their magnetic fields, which are very different from gas giants and all other types of planets. They'll also want to study the heat released by both Uranus and Neptune, which both have average temperatures of around -200 degrees Celsius. All giant planets are meant to be very slowly cooling down, as they release energy gained during their formation. This heat release can be detected in Jupiter, Saturn, and Neptune. Uranus, however, doesn't seem to release heat, and scientists don't know why. If you like this video, please consider subscribing and click the notification bell so you do not miss any upcoming videos.